All right, so I think this is recording. Let's take a look at this quadratic inequality. We have it compared against 0. There is no greatest common factor. Well, I take that back. There is a greatest common factor, an x. But I like to have my leading coefficients be negative. So the first thing I'm going to do is multiply both sides of this inequality by -1. That's going to make this x squared plus 2x. And I'm going to have to change the direction of my inequality, and that is less than 0. So like I say, rather than proceed with the next method, instead I have two terms, and what's common to both terms is x. So I can factor this as x times x plus 2. Now, this is going to divide my number line into 3 regions, and I take each individual factor and set them equal to 0 and solve. Well, x equals 0 is just 0, and x plus 2, when you set it equal to 0, that's a -2. So make sure that when you're filling out your number line, that negative number, that you have the correct order of the numbers. A -2 is to the left of 0. So we call these points critical points, or they're often called that. And I need to make a decision now whether to include those or exclude those from my solution set. Since the original inequality is a strict inequality, I'm going to leave these hollow. I don't see this underline. If it was underlined, I would shade both of those in. All right, so these two numbers divide my number line into 3 regions that I'm just going to label A, B, and C. So I'm now going to proceed in a table, only because a table is a nice organized way to proceed. Later on, when you get better at this, I'm sure that you'll do this table more or less in your head. So I can write the original inequality, or then I have it in factored form. And it's often easier for me to do the arithmetic if I have it in factored form. Then this last column, I'm going to refer to it as the truth column. And I believe that you'll see why in just a second. All right, so for my test point from region A, a value, a real number that is less than -2 and is easy to do arithmetic on, is -3. So when I replace x with -3, what do I get? Well, I get -3 times -3 plus 2 is a -1, and negative times a negative is positive, but positive numbers are not less than 0. That's a false statement. So none of the points in that region, none of the points in region A are going to be in my solution set. Oh, excuse me. But I still don't know where my pause button is. I'm sorry you had to hear me cough. All right. Between 0 and -2, I'm just going to pick -1. When I replace x with -1, I get a negative times a positive, because -2 plus 1 is 1, and that's a negative number, and hey, that's a true statement. And in region C, a number that is bigger than 0, I'm just going to pick 1. So I have 1 times, well, 1 plus 2 is 3. 1 times 3 is 3, and 3 is not less than 0. That's a false statement. So I'm not going to include any of those points in my solution set. So the only one that I'm including in my solution set is this region B. So all of these points in that region get shaded. They're all in my solution set. I'm now going to describe that solution set using inequalities. We'll soon see in the next skill packet that we'll describe all of our intervals in the future using what they call interval notation. And every once in a while you may see a video that does have interval notation that's presenting it a little bit early for us. But hopefully you can look at the picture and see how to write it as an inequality, at least until we get to the description of interval notation and practice it a little bit. All right, so there's my final answer. I hope that helps. Don't be afraid to ask questions, and I will talk to you later. Bye.